Today, we'll tackle series circuits across a range of scenarios. In this case, we are solving for the missing resistor and voltage drop in each resistor. The Ohm's law triangle will be your best friend throughout our exploration of circuits, which could be solved as V R. Starting off, we are given the total voltage and current. Since we know current is constant in a series circuit, we can find the total resistance by using Ohm's law, knowing that the resistance total is equal to the voltage total divided by the current total. So now if we just plug in voltage total divided by 1.2, we come out to roughly 10 ohms. Now using Kirchhoff's law, the total resistance in a series circuit equals the sum of all the resistances added up together. So then that means RT equals R1 plus R2 plus R3. If we plug in, we know that the total resistance is 10 ohms, R1 is 4 ohms. We don't know R2, and we know that R3 is 5 ohms. Now solve for R2 is simply just 1 ohm. Now let's get into voltage drop. Using also Kirchhoff's law, we know that current is constant in a series circuit and voltage disperses itself across each resistor. So now if we were to solve for the voltage drop in the first resistor, we would use Ohm's law of voltage 1 is equal to resistance 1 times the current 1. We know that resistance 1 is 4 ohms. 4 ohms. And we know that current is constant, so it stays as 1.2 amps. Throughout, solve, we get 4.8 volts. Now, if we just repeat this process, then finally for V3 equals to resistance 3 times 3 is 5 ohms times 0.28. 6 voltage. Now we could confirm that it adds up to the total sum with also using Kirchhoff's law, which is Vt equals V1 plus V2 plus V3. We get V1 4.8, we get 4.8 volts plus 1.2 volts plus 6 volts. We know that total is equal to 12 volts. And if you add these up, it should equal 12 volts. And then these will be your total, these would be your voltage drops across each resistor. This is the check. And here we have each resistance solved. In this series circuit, we're given the total current, we're giving each resistance across each resistor, but we don't have the voltage and we do not know the voltage drop. Okay, first off, Always start with Ohm's triangle. If you don't know my heart, just read that. Instantly off the bat, we know that voltage total is equal to I total times the resistance total. Now, using Kirchhoff's law, we solve for RT, the unknown value. We add up all the resistors, and that will give us our total. RT is equal to 23 ohms. Now we know our total current, which is 4 amps. Plug in VT is equal to 4 amps times 23 ohms. So now we know our total voltage should be equal to 92 volts. Now, if we want to solve for the voltage drop, we know again, Ohm's law, that V1, so voltage 1, is equal to resistance 1, resistor 1, times the current in I1. But since it's a series circuit, the current will always be the same since it's constant. So V1 is equal to 5 ohms times 4 amps. And we're given V1 is equal to 20 voltage, 20 volts, excuse me. I'll repeat this. Okay, now that we have all of our voltage drops, we can confirm using Kirchhoff's law, which again is VT is equal to the sum of so we have 20 plus 36. This should give us 92 volts on both sides. And that's how you solve when you are not given your voltage. Okay, now we have the series circuit. We are given the voltage drop of V1, V2, V3, and the total current. We will be solving for the resistance in each resistor and the total voltage. Once again, can't forget, start off with Ohm's law, or Ohm's law triangle, V over IR. Now, instantly off the bat, we know we could solve for the Kirchhoff's law. Using Kirchhoff's law, we could solve for the total voltage, which is VT is equal to the sum of the voltage drops. 3, plug in, we have 3 volts plus 4 volts plus 6.2, and our total voltage should be roughly around 13.2 volts. That's our total voltage. Now, if we want to solve for our resistance, we know the total current. Using Ohm's law, we know that R1 over I1 we're given voltage 1 is 3 volts, and we are given the total current, and we know it's a circuit, so the current is constant, just 2 amps, and then our R1 is equal to 3 over 2, which could also be just written as 1.5 ohms. If we repeat this for the others, R2 equals V2 I2 4. Now, using Kirchhoff's law, we can confirm or solve for total resistance, which would be RT equals the sum of all resistors is equal to 1.5 ohms plus 2 ohms plus 3.1 ohms. We have our total resistance as 6.1 ohms. Now, we could also confirm this because now we have the total voltage and we're also given the total current. So, using Ohm's law once again, we know that RT, or resistance total, is equal to the voltage total divided by the current total. In this case, our voltage total was 13.2 volts. Current total was 2 amps. If we solve, it will give us 6.1 ohms, matching up with this. And that's how you solve without